Howdy folks, Mr. Reed here, and welcome to One More Question. So I'm going to be taking a look at simplifying a kind of cruddy, big, clumpy expression, specifically one that has a bunch of exponential statements that have similar bases but fraction exponents. So we're going to have to use exponent laws while dealing with fractions at the same time. So if you want to see that done, you're in the right place. So let's get to it. Okay, so first thing first, I'm going to write down, as I said, that really largish, clumpy expression that has y to the 2/3 times x to the 7/8 over x to the 3/8 times y to the 1/2, all to the power of 3. Luckily, we have a whole bunch of fractions, which my students love, so they'll feel right at home with this. What I really mean is they seem to hate fractions, so hopefully with a little bit of practice that will change, because fractions are wonderful. All right, so we have the same base here and here, so we're going to take those two pieces and put them together. And we have the same base here and here, so we're going to take those two pieces and put them together. Now, when we do this, we are going to be dividing the bases that are the same. So the rule for that is we can subtract their exponents and make it into a single statement. So we're going to take the x to the 7/8 and we're going to subtract the base that's down below, which is 3/8. Luckily for us, this already has a common denominator, so this is going to be nice and tidy. We can keep that same common denominator of 8 and subtract the exponents. 7 minus 3. Subtract the numerators. 7 minus 3 is 4. And so we're left with x to the power of, we can reduce the 4/8, divide by 4 up top, divide by 4 down bottom, and get 1/2. That's really nice. Now let's move over to the y's. So we get y to the 2/3, subtract the exponent that's down below, which is going to be 1/2. Unluckily, this time we do not have a common denominator. So we have a denominator of 2 and a denominator of 3. So we need to find the smallest number that both a 2 and a 3 divide into. Obviously, it's not 4. 6 works. So that didn't take too long. We're going to put both of these fractions as denominator 6 fractions, still being subtracted. So how did I get from a denominator of 3 to a denominator of 6? We multiplied by 2. So I have to multiply by 2 in the numerator as well. Gives us 4/6. If we are to do the same thing in the second expression, we would have a denominator of 6. How did it get there? We had it through 2 to start with, multiply by 3, multiply by 3 up top as well then. So we get a 3 in the numerator. That is going to be 4 minus 3 in our numerator, give us 1 over that common denominator of 6. So what this boils down to is we have been able to make the x into a single expression that just has a 1/2 exponent, and the y into a single expression that just has a 1/6 exponent. This is still all to the power of 3, so when we take an exponent outside of what's going on here, we can apply it to both of the factors that are being multiplied together. So it would look like this: x to the 1/2 all to the power of 3 times y to the 1/6 all to the power of 3. So the power of 3, or the exponent 3, can move into both of those positions, and then we get the rule where an exponent raised to another exponent, we can multiply. So we get 3 times 1/2. We multiply the 3 times the 1 in the numerator and get x to the 3/2. And we could do the same thing with the y. 3 times the 1 gives us 3/6. 3/6 reduces, divide by 3 up top, 3 down bottom, and we would get 1/2. So I'm going to leave it at that. We could fiddle around with it a little more, put it actually in a radical type expression, but I'm going to say that this is x to the 3/2 times y to the 1/2. So one of the biggest things to do when working with this sort of expression is make sure that you're comfortable with the idea of how to deal with fractions, specifically adding and subtracting, multiplying and dividing fractions. You might be able to get away without the division, but the other 3 operations are going to be really important. And that's going to be this sore sticking point for most people. So if you need to review how to deal with fractions, go do that. It will be worth your time. You come back to this stuff and it'll be a lot easier. So hopefully you found that one helpful. If you did, like, subscribe. And as always, take care, folks.